Today we're going to continue learning about trig functions and spend most of today's lesson on the unit circle. We're going to start off by learning about quadrantal angles, and quadrantal angles are always using the unit circle. Quick reminder from the previous lesson, if you're using the unit circle, that means that the radius is 1. Anytime you see the unit circle, you have to assume that. So when the terminal side of an angle that is in standard position lies on one of the coordinate axes, the angle is called the quadrantal angle. A quadrantal angle is one that is in standard position and has a measure that is a multiple of 90 or pi over 2 radians. So if we look at my table here, I have 4 different quadrantal angles. And these angles are all given to you in positive values. However, remember that you can have negative angles. They do exist and they will correspond with these values that I gave you. They will just work in the opposite direction. So my note right there just says that these are all positive. Negatives exist and they will correspond with these angles. If we start in the box all the way to the left, we're looking at 0 degrees. 0 degrees is also 360 degrees if you were to make one full rotation around the coordinate plane. And 0 degrees is 0 radians. However, if you were to use 360 degrees, 360 degrees is 2 pi radians. If you were to reference the negative angle, like I mentioned, you would have 0 degrees, or you would have 360 degrees. Oh, I meant to say negative on both those. Negative 0 degrees, negative 360 degrees, or you would have negative 0 pi or negative 2 pi. So those are your options for negative values in this angle location. So we're talking about the angle being right there. If you have a angle in standard position graphed on the initial side and the terminal side is at 90 degrees, this would be a 90-degree quadrantal angle. This happens at the point 0, 1. Remember that the radius is 1, so when we say 0, 1, that's telling you the length of this side is 1. 90 degrees is comparable to pi over 2 radians. And if you were to graph this angle in the negative direction, say you were to graph this angle going in this way, you would say that it's either negative 270 degrees or negative 3 pi over 2 in radians. That's if you work in the negative direction. For the next point, we're looking at initial side at 0, terminal side at 180 degrees. 180 degrees is comparable to pi radians. This point is located at negative 1, 0, and that's because the length of this part here is 1 unit. Of course, 1 unit in the negative direction on the y-axis. Sorry, the x-axis is at negative 1. If you were to graph the same angle in the negative direction, in this case you would be at negative 180 or negative pi. And lastly, if you graph initial side at the positive x-axis, terminal side on the negative y-axis, you're looking at a 270-degree angle with a point, a point located at 0, negative 1. This is comparable to 3 pi over 2 radians. And if we were to write this as a negative, so meaning if we start here and go to this point, we're at negative 90 degrees or negative pi over 2. So you can find the values of the trig functions of a quadrantal angle by choosing a point on the terminal side of the angle and evaluating the function at that point. Any point can be chosen. However, to simplify calculations, pick a point which r equals 1, and that's the points I highlighted on these. So I'm talking about this point. I know I didn't mention it much before, but we're talking about this point. So if you choose that point, then the r value is 1. It's the point where your angle intersects what we call the unit circle. All right, I know I talked about this in the last lesson, but I'll just remind you. If you're writing an angle and you don't know the angle measure, you can use the symbol, it's called theta. And it represents an angle. Kind of like a variable that we use when we're solving. So it might represent a number, such as x. X might represent a number. When we're dealing with angles, we tend to use the Greek symbol for theta. Okay, number 1 says evaluate trig functions of quadrantal angles. At each indicated angle, find the exact value of the 6 trig functions, if defined. If not defined, write undefined. So we're talking about the 6 trig functions that we learned about last lesson. So you want to identify the point where the terminal side of the angle intersects the unit circle. And we're going to use the chart above to identify this. Okay, so before I scroll up to the chart, I'm just going to sketch a negative 180 degrees. We always know that our initial side is on the positive x-axis, and 180 degrees would be in the negative direction, so the clockwise direction, and it would end on the negative x-axis. So your negative 180 degrees forms this straight line here. If I scroll up to the chart above, here is where negative 180 degrees is, and it looks like the point, this point, where that angle intersects this piece, which is called the unit circle, is at negative 1, 0. So if that point, which I will sketch right here, is at negative 1, 0, that tells me that my x value is negative 1, my y value is 0, and because it mentions the unit circle, we know that our r value is 1. This here sets me up for my 6 trig functions. We're using the same values that we learned in the last lesson. So the first value is going to be sine of negative 180, which is found by your y value over your r value, or 0 over 1, which is 0. The second value is cosine of negative 180, which is found by x over r, and that would be negative 1 over 1, which is negative 1. The next value is tangent of negative 180, which is y over x. This is 0 over negative 1, or 0. The fourth trig function is your cosecant function. Cosecant of negative 180 is r over y, or 1 over 0. 1 over 0 is undefined. You can never have 0 as a denominator. The fifth trig value is secant. Secant of negative 180 is x over r. Oh, I said that backwards. Secant of negative 180 is r over x. which is negative 1 over positive 1. Keep writing the wrong thing. Positive 1 over negative 1, which is negative 1. And lastly is your cotangent of negative 180, which is x over y. That's negative 1 over 0. This is an undefined value. So your 6 trig functions are 0, negative 1, 0, undefined, negative 1, undefined. Okay, the next problem, we're doing the same thing. So the directions tell us this is on the unit circle. So automatically we know that our R value is 1. I also am in need of sketching the angle of 3 pi over 2. And 3 pi over 2, if you remember from the chart above, is the equivalent of 270 degrees. So if I was to sketch this angle in standard position, I have my initial side on the positive x-axis. Counterclockwise to 270 is this angle here. And we're looking for the value of that point. So the point where the graph intersects what would be called the unit circle. So intersects what I just sketched as the unit circle. If I scroll up, here's where my 3 pi over 2 radians is. It looks like that point is at 0, negative 1, which I would have already known without looking at the chart if you just remember that the radius is 1. So I know that this point is at 0, negative 1. This gives me an x value of 0, a y value of negative 1, and because we're on the unit circle, an r value of 1. Your 6 trig values. The first one, sine of 3 pi over 2. That's equal to y over r, or negative 1 over 1. Simplifies to negative 1. Second trig value is cosine of 3 pi over 2. This is x over r, or 0 over 1, which is 0. Third is tangent of 3 pi over 2. Tangent is found by y over x, or negative 1 over 0. That cannot happen, so our tangent value is undefined. Fourth is your cosecant of 3 pi over 2, found by r over y. That's equal to 1 over negative 1, or negative 1. Next we have secant of 3 pi over 2, r over x, or 1 over 0, which is undefined. And the last trig value is your cotangent value. Cotangent of 3 pi over 2 is equal to x over y, or 0 over negative 1, which is 0. Your 6 trig values are negative 1, 0, undefined, negative 1, undefined, and 0. So to recap this lesson, basically everything we went over in the last lesson, except for you're focusing on quadrantal angles, and these are angles that work with the x or y axis, so they're multiples of 90 degrees. You could have a quadrantal angle at 0. This angle intersects at 1, 0. It intersects the unit circle at 1, 0. You could have a quadrantal angle at 90, which intersects the unit circle at 0, 1. A quadrantal angle of 180, intersecting at negative 1, 0. Or lastly, a quadrantal angle intersecting the unit circle at 270, which has a point of negative 0, negative 1. And for the last section, which I'll let you work on your own, the answers are posted on my website. But I just specifically asked you for a single trig value, not all six. So for example, in number one, I'm asking you for the secant value of 4 pi, and that's greater than 360. It's still a quadrantal angle though. So instead of finding sine, cosine, tangent, cosecant, secant, and cotangent, I am only asking you to find the secant on number one. Number two, you're only asked to find cosine. Number three, cosecant. Number four, cotangent. So you're finding 4 trig values for 4 different quadrantal angles. Answer key is posted on my website. Let me know if you have any questions.